Okay, this is finding the coordinates of vertices of polygons. So basically all you're doing is using the properties of polygons to figure out what the ordered pair values should be. The kicker is when I say ordered pair values, for your x value and your y value, you're not actually going to have numbers. We're going to use letters. So this is a la geometry, or sorry, geometry a la algebra. All right. So let's take a look at what we have. We have a rhombus here, and they have labeled up 4 points, A, B, C, and D. They gave us the coordinates for B, which starts at the origin, so it's at 0, 0. And they also gave us the coordinates of point C, and that is at negative F, so I'm going to label this down here. That's my X value. This here is going to be at my Y value, which is at G. So now I have a sense of what's what here. And the thing that we need to remember about rhombi is they're symmetric. So the distance from C to the y-axis is going to be the same as the y-axis to A. And the distance from B to D is going to be half of the distance from B to C. Okay, so what we're going to do is let's start with our D first, our D point. If B starts at 0, we haven't moved at all for our y value by the time we get up to D. So we already know that our y value for D is going to be 0. It didn't move at all. What we know from B to D is we go up as far as G, that will give us this point. And if we go up double that amount, we're at D. So like I said, it's double that. We don't have a number there, so we want to just designate it as twice the value of G. Whatever G is, we would double that, and that would be our new point for our y value. For A, we're going to do something a little bit similar, just that we need to do it for both of the letters. So we know that from here to here, the absolute value would be F. We went over negative F, so that means that to reach A, we have to go over a positive F, and that will be our new X value. So X will be F. For the Y value, from C to A should be the same exact height. That would represent our Y value of C. So the height is also going to be at G. Sometimes it might be easier to put some numbers in for it. Maybe we'll try that strategy on the next one. But most of it's just remembering that there's symmetry. Whatever this value is, it's going to match that value. Whatever this value is, it's going to match that value. So just kind of thinking about all those things, or marking up your picture would also help too. Let's try another one. All right, for our next example, we have a parallelogram, and that's the symbol for parallelogram. And we have we have 3 vertices labeled and 1 that we need to find. So we need to find the x and y values for D. So let's mark up our parallelogram. These guys have to be congruent, and these guys have to be congruent. Having marked that up, we now know that the height of E has to equal the height of D. And this is going to be all about the y value. Y value talks about up and downness, so that's the y value. The beauty of this is they gave us the y value for E, it's A, so for D our y value also has to be A. It also has to go up a height of A units. The less obvious type of, I guess, value would be our x value. We don't know clear cut how many units that is. We know that it's definitely more than C, because C units goes from here to here. But it's going to be a little bit more than that. So knowing that ED has to be the same length as FG, we can look at the x value for F. It's at negative B. So if we can change this and add a positive B to our C, we'll get the right number of units. We'll go all the way over to C, and then we'll go over B more units, and then we'll end up at the right spot for D. So the way that we would write that is we would just write it as C plus B. You could also have B plus C, either way. It's a little bit awkward looking, but that's kind of why, that's how they run with geometry. They integrate a lot of the algebra with it to see if you can figure out abstractly what a distance might be. Let's try another one. Alright, this third figure we have, it's an isosceles triangle. And if you remember what an isosceles triangle means, it means that we have 2 congruent sides, and these 2 guys are the ones that are congruent. It also means we have congruent angles. I'll mark those up. We don't really need that for this problem because we're just trying to figure out side lengths. So C is at the origin, E is kind of floating somewhere around, and D is what we're interested in trying to come up with. The other thing about isosceles triangles is if we cut them down the middle right through their vertex, not the way I've drawn it, but if we fold it on that line, these two halves would line right up. That's called symmetric. So they would match up. So that means that this distance here would have to equal that distance there. And this distance here would have to equal that distance here. So that's just how it works out with isosceles triangles. That's really good because if we look at E and we bring our line down, this x value here that it would hit would be u. So if we know that from here to here is u, we know that from here to here is also u. So u plus u would give us 2u. So our x value for D would be 2u. So just kind of applying a little bit of what we know about symmetry. The good part about D for height, D is sitting on the x-axis, so is C. They have no height at all, so the y value is just going to be 0. And let's try one more. Alright, I thought we'd look at one more parallelogram one just because it takes a little bit more thinking to get that x value a little bit. So they gave us a parallelogram, and we know that this guy's equal to that, this guy's equal to that. We have to fill in the x and y value for C. We'll start with the y value because the y seems to me to be the easier one. The height of F is going to equal the height of C. So again, that's your y value. As soon as you can talk about heights being the same, then you're going to be looking at the y value. So the y value for F is Q. So our y value for C is going to be Q as well. Now we just need to figure out what our x is going to be. So we know that the distance from here, from E to D, is R units. Well, C doesn't quite go as far as R. So we know that it's going to be something a little bit less than R values. So how much do we need to subtract out? Well, this little piece, let me just change colors for a second. This piece here should equal the same as this piece. This is what we need to take off. We need to remove this from here, and that will give us what we're looking for. And what would be the x value of C. So since we don't have numbers so we can concretely subtract it out, we need to think about it. We need to take our R, which is our x value, and we need to subtract out this piece, which would be a p value. So the value of our x value is going to be R minus p. And there you go.